Which expression is equivalent? So let's start with the original problem. And I'm going to write 5 to the power of negative 8 divide by 5 to the power of negative 7. That fraction is multiplied by 5 to the power of 0. Typically, in problems like these, we would, as we move from left to right, we'd like to simplify this fraction to start. And I'm going to work these out horizontally, which means I'm going to go from left to right. So step number 1 is I want to focus on simplifying this fraction. I do notice that I have a common base of 5, which means that I will subtract their exponents. So 5 to the power of negative 8, and then I need to subtract that power on the bottom, and that power on the bottom is in fact a negative 7. And then I'll go ahead and just rewrite the rest of the problem. 5 to the power of 0. Okay, so now let's simplify this. Whenever we have a negative negative, that's going to switch to an addition sign. So if I move this all to the next step over here, 5 to the negative 8 plus 7 will result in 5 to the power of negative 1. So this first part here, I just simplified to 5 to the power of negative 1. Then I got to rewrite this times 5 to the power of 0, so 5 to the power of 0. And now it's a lot easier. It's almost like the lesson we did previous to this. Now I'm doing 5 to the power of negative 1 times 5 to the power of 0. And in that step, because I have a common base of 5, I'm going to write 5. And I will in fact add negative 1 and 0. So I'll put negative 1 plus 0. And then that would simplify. That's supposed to be an arrow there. That would simplify as 5 to the power of negative 1. We don't see 5 to the power of negative 1. So what I'm going to do is I'm going to make 5 to the power of negative 1 a fraction. I'm going to put it over 1. And then my desire is to make this a positive exponent by moving 5 to the negative 1 from the top of the fraction, or the numerator, to the bottom of the fraction. And I guess I'll just move down here since I've got more room here. So then I've got my fraction. But again, 5 to the negative 1 moved to the bottom, so it's still a positive 5. But importantly, that negative 1 exponent switched to a positive 1. And then we're going to leave 1 in the numerator. So it's 1 over 5 to the power of 1. And recall that having an exponent of 1 as the exponent or power is optional. And so this would be the simplified answer for what we got as 1 over 5 to the power of 1, which is just 1/5. Okay. The other type you'll get is where you have a complex fraction. So let me give you an example for that one. So again, start with the original problem. So I've got 4 to the power of negative 3 multiplied by 4 to the power of negative 2. And that's all in the numerator. Underneath that, in the denominator, is 4 to the power of negative 3. When you're dealing with complex fractions, the first step is to always simplify the numerator and the denominator before you try and simplify the whole fraction. So this is where I'm going to start. I'm going to simplify this part right here by combining 4 to the negative 3 times 4 to the negative 4. And the way we would show work for that, because we're multiplying and we have base 4, we're actually just going to add those exponents together. So I'm going to put 4 to the negative 3 plus a negative 2. And that's still over 4 to the negative 3. But the fraction looks a lot simpler now, I think anyways. Okay, moving to the right, negative 3 added to negative 2 will result in 4 to the power of negative 5 over 4 to the power of negative 3. I think that's a lot easier. Again, we simply took the negative 3 and we added it to negative 2 to get negative 5. Now we can go ahead and do our division because we've simplified the numerator, and we have 4 to the power of negative 5 divided by 4 to the power of negative 3. Because we have the same base, I'm going to write 4 to the power of negative 5, and we are dividing, so I am going to subtract, but I will subtract that negative 3 from the bottom. So a negative 5, notice we have a negative negative here, that's going to switch to an addition, so it's really negative 5 plus 3. Moving it over here, we have 4. What's negative 5 plus 3? If you said negative 2, you got it. But now, like we did in the last problem, we did have a negative exponent The nice thing is that does have 4 to the negative 2, so that's going to be this one here. But just as a quick review, if I didn't have 4 to the negative 2, recall you could make that a fraction by putting it over 1. And then you could make this a positive 2 exponent by moving it to its reciprocal position, which means that when I write it down here, there's my fraction bar. 4 goes to the bottom, but that negative 2 exponent will turn to a positive 2, and then we'll make it a fraction as 1 over 4 squared. Or that could be technically 1 over 16, because 4 squared is 4 times 4, which is 16. And there you have it. You got a couple examples for dealing with the division property of exponents.